Python peeps, now we've learned about how to use the accelerometer. Let's have a quick challenge exercise. We'll create a small challenge project here, the Don't Move My Stuff alarm. So if you want to take the challenge right away, this is what we're going to build. The Don't Move My Stuff alarm is going to be, once we turn it on, button A will arm the alarm, so it will begin to listen in to see if the device is moved. Button B will turn off the alarm so that it won't sound anymore. And if the item is moved, it's going to light up, the CPB is going to light up in red, and it's going to play an alarm sound. Now you can pause right here and give this a shot. But if you want to unpause or watch some of the steps that I'm going to do in order to build this, let's go. Now the first thing I'm going to do is I am going to run the program that we wrote during our last exercise. Now remember, this prints out the 3 axes of the accelerometer, so I'm just going to click on Save to Run, and then Serial to show the print output, and Plotter to show the plotting output. And I'm eventually going to use this alarm on my iPad because my family members are always taking my iPad when I don't want them to. So right now it happens to be plugged in, but eventually I'll unplug it and I can turn on my CPB's battery pack, and that will power it without being wired. So now if I look at my plotter output as well as what's printing out in the serial console, I can see that the X and Y are roughly around 0 and the Z axis is up around 9. Now while my code is executing, I'm going to move around my CPB and see what the output looks like when this thing is in motion. And I see some spikes, I see changes in output. What I'm going to do now is stop the execution. So if I click in the serial monitor and type Control-C, that will stop my code. So now I can scroll back up in the output in the serial monitor here and take a look to see if I can find out where the spikes occurred. And it looks like one of these spikes occurred up where I've gone above the reading of 11 on the Z-axis. And if I just eyeball the readings on the right, it looks like the spikes go up maybe around 2.5 in the positive direction, a little bit more than 2.5 in the negative direction for both the X and the Y values. So if I reach any of these values, then I know things have been moved. So I'll close the serial monitor, the plotter, and I'll scroll down. I'm going to get my accelerometer readings, but instead of printing them out, what I'm going to do instead is I am going to say if Z is greater than 11.0, and I'm going to use an OR statement to check to see if there's tilting in any direction. So I can say here, or X is greater than 2.5, or X is less than negative 2.5, or Y is greater than 2.5, or Y is less than negative 2.5. That means if I've got tilting in any direction, left to right, up to top, or if I've got a sudden pick up, I'm going to put in a colon in here, and what I'm going to do is I'm going to set off my alarm. So why don't we just go ahead and do pixels.fill, open with a red and close, and then I'm going to play a sound. And I've queued up a sound. I'll show it to you in Audacity. This is an especially obnoxious alarm sound that I found on the internet. I've saved it in the 22 kilohertz format in mono, not stereo, as a 16-bit WAV file. If I go over to my desktop, I'm just going to take this file called siren.wave, and I'm going to copy it into my CircuitPy so that it exists there. I'm going to make sure that I know what it's named. It's named siren.wave. And now I can return to moo, and I can call my playfile function that I wrote earlier, saying playfile, open parentheses, double quote, siren.wave, close double quote, close parentheses. And that will play the alarm. Now, since we're testing and we haven't done any of our buttons to arm the alarm or disarm the alarm, what I'm going to do is just to print out the values that are triggering the alarm. Because as I'm experimenting with these, sometimes I find that the values that I initially thought were going to be good are a little bit too sensitive. So what I'm going to do is I'm going to print whatever triggered the alarm in here. Remember, we're printing a tuple, so there's 2 sets of parentheses here. And the tuple is actually the thing that's the inner layer parentheses, X, Y, and Z. Before I actually go ahead and save, what I'm going to do is open up my serial monitor and my plotter here so that I can go ahead and see which values are triggering. And oh, 13 shows up right away. So that means I should probably increase the value that I'm testing for in the Z-axis. So what I'm going to do is, let's see, close up my serial monitor, close up my plotter, go back up here and change 11 to, oh, maybe I'll do, instead of 13, I'll do, maybe 14 is a good one. So let's see how this works. If I go ahead and now open my serial monitor and my plotter, I'll do save again. Nothing is being triggered, but what happens if somebody comes over here and tries to steal my iPad? Whoa, it goes off, and there we go. Now we see we haven't changed our color. We haven't shut off the lights, but we're well on our way to getting our alarm working. And so now I'll close up my serial monitor and plotter, and we can think through what do we want to do in order to be able to arm our alarm. Well, one thing we can do is create a true-false variable named armed. Now we'll initially set armed to false, but once you click on the A button, then we'll set armed to true. So what we can do in our if statement is we can check to see if armed is true and we've reached any of the values in the X, Y, or Z axis in these or statements here. And if that's not clear right now, we'll enter some code and see if that clears things up. So you can do this really any place before your play file definition. I'm going to type in armed equals false. And that means when our program is first running, our alarm is not armed. And now I'm going to scroll down to my if statement and I'm going to put parentheses around this giant set of or statements here. Now that means this whole set that's inside the parentheses is going to return either true or false. And then after this, I'm going to type in and then space, and then armed. Now remember, armed is true or false. It's initially false. So that means none of the statements that trigger the alarm are ever going to go off until I set armed to true. How am I going to set armed to true? Well, I'll do this just above my if statement. And I'll type in a statement that says if button underscore capital A dot value colon. So that's checking to see if button A has been pressed. Then what I'm going to do on the indentation there is I'm going to say armed equals true. So if you press button A, we set the alarm so that it's armed. And now if I exceed any of the threshold conditions down there, I am armed at this point. What I want to do underneath is I want to put an identical statement that says if button underscore B dot value colon, and then in the next line indented, I'm going to say armed equals false, and that disarms my alarm. So anytime you press A, we're arming the alarm. Anytime you're pressing B, it's not armed. By default, we will not arm the alarm. So, and another thing I think that we'll do as well is we can see that we fill the pixels with red, but let's see if we disarm the alarm. So we'll keep them red so we can tell, hey, even if it's not playing a sound, if somebody's got in and messed around with our stuff. But if we disarm the alarm, what we'll do over here is we'll say pixels.fill black. And one more thing, so that this can reset every time we restart our app, what we'll do is we'll go up here and we'll set initially the colors to be black. So right under the colors, you can really put it any place above your while true loop. I'll say pixels.fill and then black. So this way, you know, if we had our alarm off, but then press saved and restarted our program again, we'll go ahead and set things black. And during testing, I was noticing that it was going on when I pressed button A and I jostled it a little bit. So what I'm going to do is add a slight delay of 2/100ths of a second right after I either click A or click B, and hopefully that won't prematurely set off the alarm. And now let's see how things work when we save it, and I'll arm it. Oh, and I moved it, and it detected a movement. Oh no. Can I turn my alarm off? Yes, and I can wiggle it around, no problem. What if I arm it? Now I wiggle it around, somebody's trying to nab my iPad. You're caught red-handed! And even if this goes off after 5 seconds, the ring is still red, so I can tell the alarm went off. Now you can turn this off. You just wrote a program to create a motion-sensitive alarm using an accelerometer. Good work, programmer. Keep at it.